Hi, Assalamualaikum. Today I would like to continue on our previous discussions on single index model. We are still in chapter 3, yeah? So, which is SIM. So, as I remember, we already managed to discuss on calculations of single index model for a single security, but let me recap on that. So, single index model has two types of calculations. The first one, when you want to calculate a single securities. Secondly, if you want to calculate for the risk and return for a portfolio. Alright, so for single security, of course you want to search for the return and also variance. For expected return for a single security, okay, by using single index model, okay, what you need to do, get the alpha of that security plus beta for that security and multiply with return on market. Okay, this is for your expected return for a single security. So alpha for that particular security plus beta for that security and multiply with return on market. Whereby for the variance, okay, so you need to search for the variance on that particular asset equivalent to beta for that particular asset by the power of 2 variance on market plus another component here is what we call as residual variance. So this is what we call as residual variance. Okay, for SIM, the coverage, everything would be given to you as what the example that I shared with you earlier on. And another component that you need to search under a single security is covariance for that particular security, assuming asset of I and J. Alright, so the formula would be the beta for I multiply beta for J and multiply with variance on market. So let's just crunch the formula first. Okay, once you well versed with all the formula, let's look at the example that I also shared in the class, yeah, of 4 assets available of J, K, L and M. Alright, so as mentioned just now, all the components here, alpha, beta and also residual variance already been given to you. You can just slot in the figures. So the first questions that you need to answer is what will be the expected return for each of the securities. So therefore you need to compute the expected return, for example, for the first asset. Alright, so alpha for J is 0.5 plus beta of J is 1.2 multiply with the return on market already been given to you, which is 5. So you can get the answers of 6.5. And you may continue to the rest of every single assets as attached to example there. So you can search for the return on K, expected return for L, and expected return for M. So to continue this, alright, expected return for K, so search for K information. The alpha is 1 plus the beta for K is 1.5 and the return on market for K is also the same, it's 5. So you can get the answers of 8.5. So once you compute for all the assets there, so you can get all these answers: 6.5, 8.5, 6.0, 4.5. I believe we have done this in the class before we start our holiday. Alright, to continue on the questions, next we need to search is variance. So based on the formula given just now, variance would be whatever beta power of 2 multiply with variance on market plus whatever residual variance of that particular asset. So for variance for the first asset, which is J, so look at the beta for J, which is 1.2, power of 2, variance on market, you have a standard deviations which is 6 there, so 6, because this is variance, so you have to make it as power of 2 plus residual variance for J, which is 6. So you can get the answers there, which is 57.84. Okay, you can proceed with the rest of other assets, which is K variance L variance M. Alright, so for K, for example, the beta for K is 1.5 by the power of 2 multiply with variance on market, is the same thing, plus residuals of K, which is 10. So you can get the answers of 91, and you may proceed for the rest of other value. Alright, once you completed the calculations, this is the answers that you may get. Alright, for variance for J is 57.84, variance for K is 91, variance for L is 31.04, and variance for M would be 16.96. So the last steps in calculating the return and risk for a single security by using single index model is to calculate the covariance of returns. So when you say covariance, you need to have a pair of assets because you want to see the movement of these two assets. So you have, as I discussed with you earlier on, if you have 4 assets, you might get 6 pairs of covariance. Alright, so the first pair will be JK, covariance for JK. The next one is covariance for JL. Next one is covariance JM. Okay, next is what is the covariance for KL? Covariance of KM. And last but not least, covariance for LM. So you have 6 pairs of covariance to be calculated altogether. Alright, for the calculation for the first covariance, which is J and K, so whatever beta for J, so look at the components here, which is 1.2, multiply with beta for K, so it's 1.5, multiply with variance on market, which is 6 power of 2. So you may get the answers here, which is 64.8. Alright, so you may proceed the next one, covariance of J and L. So beta for J is 1.2, beta for L would be 0.8. And then you multiply with the variance on market. So everything should be the same. So once you proceed with the rest of other covariances, alright, so you may get all these answers. Alright, for covariance KL, you can get 43.2. Covariance for KM, you can get 32.4. And last but not least, covariance for LM, you might get 17.28. So overall, we have done for the first part of calculations of return and risk together with covariance when we want to calculate based on single index model. Because why we want to use single index models? Because we have more than 3 assets. Alright, so it's better for us to use single index model to replace whatever calculation that we have done earlier on. So the next calculation I'll share with the next video. Thank you.